Hello class, today we're going to start a new unit on discrete functions. The first lesson for this unit is called Arithmetic Sequence, and the textbook reference for this lesson is in 7.1. So we're going to learn about arithmetic sequence by refreshing your memory about patterning. So in this example 1, we see a series of figures. Figure 1 has 1 square. Figure 2 has 3 squares. Figure 3 has 5 squares. If I were to use this pattern and figure out what figure 4 would look like, it looks something like this. It would look something like this. It would look something like this. It would look something like this, which has 7 squares. Figure 5 would follow the same pattern and look something. Figure 5 would follow the same pattern and look. Figure 5 would look similar and look. Figure 5 would have the same pattern and will look similar to that, which has 9 squares. If I were to write the number of squares as a list, 1, 3, 5, 7, 9. This list is ordered from the first figure to the 5th figure. And when we have an ordered list of numbers, we call that a sequence, or a sequence of numbers. Now this is a special sequence of numbers. It's an arithmetic sequence. The reason why it's called arithmetic is that between each pair of numbers on the sequence, there is a common difference. To go from 1 to 3, there's a difference of positive 2. From 3 to 5, there's a difference of positive 2. This pattern continues between each subsequent pairs of numbers along the sequence, even if I were to continue the sequence. And therefore, because it has a common difference, this sequence is called an arithmetic sequence. This sequence is called an arithmetic sequence. So the definition of an arithmetic sequence is a sequence of numbers that has a common difference between any pair of consecutive terms. We have a formula for arithmetic sequence where we can find any term number along the special sequence. Another definition is the fact that we denote a term. Each of these numbers is called a term. So this is term 1, or the first term of the sequence. This would be term 2, term 3, term 4, 5, and so forth, to any term number. We can predict any term number using the arithmetic sequence equation, where term number is equal to the first term plus that term number. Any term number can be determined using the arithmetic equation, where we can figure out that term is equal to the first term, a, plus that term number, n, minus 1 times that common difference. So this is the arithmetic sequence equation. So this is the arithmetic sequence equation. Where a is our first term number, n is the nth term, so whatever term is along the sequence, n is the number of which the term we're looking at, and d is our common difference. We can find any term value along the sequence using the arithmetic. We can find any term value. So here above the top, I have listed out our term number. So where along the sequence is that specific value? And the sequence of numbers 1, 3, 5, 7, 9 is our term value, which is what is the actual number at that position along the sequence. We could figure out any term value using the arithmetic equation, where the nth term value, t at n, is equal to the first term, a, plus the term number, n, minus 1 times the common difference. So this is the arithmetic sequence equation. Where again, t at n is the term value at the nth term number. A is our first term. N is the term number, so where along the sequence is it? And D is our common difference. If I use this arithmetic sequence equation, I can create an equation for the example we've talked about. But using this arithmetic sequence equation, I could create an equation for this arithmetic. Using the arithmetic sequence equation that I've shown here, I can create a formula to find out the term value for any term value along the sequence in our example. So let's define the specific terms I need in the equation. A is our first term. So A is our first term of the sequence, which in this example is 1. Our common difference, we said, or D, is positive 2. So using these specific characteristics of the sequence, I can create the arithmetic sequence equation. So I can figure out the term value along the sequence if I take 1, the first term, added to any number along the sequence I'm looking for, minus it by 1, and multiply it by the common difference 2. Using these characteristics of the example shown above, I can create an arithmetic sequence equation so I can figure out the term value. I could figure out any term value along the sequence. So my general equation starts with Tn, which is any term value, is equal to my first term A, which is 1, plus whichever term plus whichever term number I'm looking for, minus 1 times the common difference, which is 2. I can simplify this equation further by expanding out this bracket and collecting like terms. So T at n is equal to 1 plus 2n minus 2. So T at n is equal to 2n minus 1. So here is a general formula so that I could figure out any term value along this arithmetic sequence. Let's try one out. If I wanted to find out what is the term value for the 10th term in this sequence, if I want to find the 10th term in this sequence, I would write T at 10 is equal to 2 times 10, because that's the term number I'm looking for, minus 1. So I would get 20 minus 1. So my T at 10 is equal to 19. So if I were to continue this sequence of numbers to the 10th term, I would find that the value is equal to 19. So use this equation and think about what each part of the equation means in terms of finding out the term value and the term number, and have fun.